Capitalism, all of the gains in automation, it goes to the owner class. All you have to do is have everyone be an owner, and now suddenly any gain in automation is a gain for everybody. If you grow just one thing, it may not grow as well as if it grows with another thing. A good example of that is called the Three Sisters method of farming.
There is definitely multi-apartment buildings or multi-families that do passive design.
$100 million that they gave to Joe Rogan that they would kind of be out if they breach contract. Is that a bigger number, or is 2 billion a bigger number?
I don't know,
It's a
Zach.
tough
This
one, I
is
know,
really hard.
and maybe
Yes.
comparing numbers is not Jeremy's strong suit. Gotta go kill a Jenny.
I still don't think you should kill her. I don't think it's a good idea.
It's a ghost, dude. Hello and welcome back to Bread Theory. Tonight we're going to be sitting in once more with Mike Hoag's Permaculture Design course through Transformative Adventures Permaculture. We're going to see the first hour of the course tonight, and tonight is going to be on the topic of polycultures. So that's a completely new word to you. Basically, what a polyculture is you may have heard of, say, the Three Sisters, where you have corn, beans, and squash all grown together. The corn acts as a pole for the beans to grow up, so they aid the beans' growth. The beans fix some nitrogen, which is really important for growing corn. And then the squash shades the soil and prevents compaction and evaporation and cuts down on the need for watering for the other two. And then takes some of the nitrogen from the beans as well. So they all benefit each other. So that's a very basic version of a polyculture, but it can be much larger and more complex and resemble, a multi-layered ecosystem as well. So we're going to get, I think it's just about time for class to start. So I'm going to see if everything is ready, and we'll be looking in on the class as soon as we possibly can be. And of course, I will be here. This is a live class, so if you have any questions, you can just put them up in the chat, and I will relay them to Mike as we go along. Or you can ask me too, because I also have a permaculture design certificate. I've been through this sort of coursework before. But yeah, it's always a fun time getting to see Mike in action, because his classes are top notch for sure. So if you are thinking about getting a permaculture design certificate, you should go over to Transformative Adventures. Why am I not thinking? Transformativeadventures.org, and you can see all about Mike's stuff. And perhaps sign up for the next round of classes if that's something that you're interested in. Oh, looks like I'm being let into the class. So I don't think we're quite ready to start yet. All right, looks like ready to go. So I will go ahead and share the screen, and we will get into it.
New permaculture, which is very exciting, and so today's topic of polycultures is very much on my mind. Here, let me unpause us and get started.
Recording in progress.
Hi, everyone. Welcome to our Transformative Adventures Permaculture Design Certificate course class on polycultures, one of my absolute favorite topics in all of permaculture. One of the topics that really got me interested in the whole thing, having grown up in a family that did a lot of monoculture type gardening and farming. And so this is one of the things that really transformed my gardening and transformed my whole concept of food and food systems and everything. So, as I was just saying, I'm just moving into my new place. Oh, was I cutting out? I still have a few people joining us. Today I'm broadcasting from my new spot here, new studio, and in a new house. Let's see, can we see it here? There's the lemon tree over there, and yeah, there's, you know, you got to have your branding. There's the Transformative Adventure side, and there's me. So it's my new spot. I'll have a view out the window of my main Zone 1 garden, which I'll actually show you the plans for tonight as a polyculture style of gardening. So again, polyculture is just one of my favorite topics in all of permaculture. Let me make sure I'm sharing the slideshow for tonight. There'll be lots of, oh, that won't work. That's going to be our class address. Let me make sure I have the link for y'all. Okay, now I got the good stuff. I'm back with the good stuff, sharing it in the chat. Okay, there it is. And as just an update, so I just dropped the link for tonight's presentation in the chat. There's going to be a lot of materials in the folder for tonight too, so you can open that up. So yeah, just to kind of bring you up to date again on where we're at in the process, if we're walking people through a very formal style of permaculture design process, then we will have began our adventure by talking about everything that we could imagine doing on the site, you know, all of the potential uses. We start by thinking of the human space and the landscape, so that we're really starting with the idea that we will be connected as an integrated part of the landscape, not something separate that watches over it, but something that, an element that interacts with the landscape in a beneficial way, that gets involved in the systems and becomes part of the food chain and part of the ecosystem. So we're looking at all of our potential elements. So if you've been following along in this process, at this point, hopefully you have some notes about all the potential uses you have for the property. And we've been daydreaming this whole class so far and all the different ways we could see ourselves interacting with it. We'll, of course, continue developing those over the coming months. But hopefully we've got a good start on that. The next thing that we looked at was some analysis, some observational analysis of the site, starting with things like, what are the energies, the sectors that affect the site? Things like traffic and sun and cold and all of that. And we've talked about permaculture zones, which is how our energy spreads over the landscape, as one of the major, most important factors for pretty much every element of the design, from how we'll deal with pests, how we'll deal with weeds, how we'll deal with water and fertility. Our zone analysis will be the leading way we deal with all of that. Next, we talked about some of the major mainframe elements in the system, which are going to be water and water resources, and of course, trees and our major tree crops for the site. So since trees in a permaculture system will have such an important role, we always kind of start by looking at those and listing those as well. So that finally brings us to today's topic. Once we have all of those things planned out, of what our major planting designs are going to look like. And in permaculture, that's never just going to be a cornfield. Right? It's never just going to be, well, not, I won't say never. In permaculture, you never say never, but it's probably not just going to be a cornfield. It's probably going to be multiple species. And so this next topic of planting become these.
So the science
Sounds like we. Okay. We had a little bit of a demon in the mix there, but we're back. Okay. So with all of that said, before we jump into today's topic, how are you all doing? How are you feeling about all this permaculture stuff? Any ideas that are bubbling up from any of the topics we talked about before that we'd like to bring up and check in on, or anything else that you want to bring up on today's topic, polycultures, before we get started? And we'll talk about them a little bit, have a little bit of discussion about your experience with polycultures as we before we jump in. But does anyone have any anything they want to check in on and say hello about?
Hi.
Hi, Ellen.
Yeah, I'm excited about tonight's topic. I'm curious what you think about postage stamp gardening. We've done that, and to my understanding, the polyculture stuff, we're going to be intermingling things a lot more than you do in a postage stamp garden. So I'm excited about that. And we've had some success with certain companion plantings and looking to do more of that. I'm also just excited because everything's melting and we're actually getting to see our ground right now. So we were imagining into that today, just, looking around the garden and thinking about future beds. So this will be great information tonight for that planning.
Great, I'm glad. Yeah, it's there's no hard and fast rule about how much mingling or intermingling of plants we can get. One of the rules, one of the resources that I'll show you kind of is some research that just demonstrated that it's very interesting, because almost all of our biology related graphs, whenever we graph anything, it's almost always on that Pareto curve, right? It curves. So when you do weeding work, you get the 80% of the benefit of weeding from the first 20% of your weeding work. After that, it starts to level out. So you can do like 1 million hours of weeding to keep a weed-free, completely weed-free garden, but you don't get any extra benefit of it, from that initial 20%. And it's the same thing with like pest management. And this is one of the big ideas of just like the mainstream view of pest management is IPM, Integrated Pest Management. And IPM teaches exactly the same thing, that you get 80% of the benefit from your first 20% of dealing with pests and diseases. And, after that, it levels out. Polyculture is different, because our best research so far has all shown that it's linear, that it continues in a linear fashion. The benefits are linear. So the more species we can figure out how to add, apparently, the more benefits we get out of it. I'm sure it has to end at some point. At some point, it levels off, right? But it appears from our best research, the more efforts we can make to try to grow plants together in a good way, the more benefit it has to us. Anyone else have anything they want to check in and add? Any good experience with polyculture that you've had?
Well,
I
have a little question about that. Does it apply to houseplants? Because I'm thinking like maybe I'm overdoing this, but I'm getting all these ideas about putting fava beans and stuff in the houseplants. And also larger containers. Why the hell are they in these 4x4 pots? What am I doing to myself? And then
we actually have amazing solid evidence that polyculture helps in artificial growing environments, in things like in greenhouses, and even in like the NASA studies where they've tried to create artificial environments to terraform them. They've found that the more it's monoculture, the more they end up with really terrible pest problems. And something like cockroaches or rats, if they get out of hand, they're impossible to control on these very low biodiversity systems. And one of the things that we found is that if we can take those artificial environments and make them more polyculture, it reduces a lot of those problems. I moved in with an avid houseplant gardener, Becky, here, and she has a very polyculture indoor plant garden. She's got tons of things in this cool little, based practically an artificial indoor ecosystem, and she's had very few problems at all. In fact, she brought home a plant that had like a mealybug infestation, and another one that had some like aphids and stuff. And I was expecting those problems to just destroy the whole indoor garden, and they did. So there's something to be said for culture, even in artificial environments. So I will add one caveat to that, Pamela, that some of the best benefits come, it's true, from roots sharing soil together. What we found.
Yeah, that sort of figures. I mean, that's what I was thinking about. Cool. Oh, now I'm inspired. I'll let you know if something fantastic happens.
Yeah, usually in the past, even my lemon tree here has always been a lemon tree polyculture, but this summer that annual understory dominated and those all died back. So now it's just a lemon tree for the winter. But probably they would go through a period of time where there was dormancy of the understory anyway. So when it gets back to summer, it's going to be a lemon polyculture again.
Yeah, we can always do fava beans. Of course, this is Portland, but I mean fava beans.
Yeah, absolutely. Hey, anyone else have anything about polyculture, this cool topic to check in on? And as always, if you're watching, the first part of this class is kind of an introduction to polyculture on bread theory with Zach. And feel free to ask him questions. I'm sure he'll relay those questions to me too. And Melanie says here, okay, so that makes me wonder about starts. Will seeds sprout better when intermingled? Well, that one actually does have an interesting issue, which is just, and we'll talk about this later. It appears that the answer to that, Melanie, is yes. If you start seeds in an environment that's a polyculture environment, which is the way I always do it, by the way, there's some research indicate they should do better than if you do big trays of just one plant. The downside could potentially be if they're sharing water and soil, then we have to be careful that that the seeds don't poison the other seeds. So we have to be careful that we're not choosing allelopathic plants. So that's one of the things we'll talk about tonight, is that some types of plants, one of their life strategies is to, in fact, here's one of these ecological rules. Most of the plants that we like to eat as humans, most of our best crop plants, fit into this category. Because I think in a past class we talked about how most of our crop plants are called productive plants. That's their life cycle strategy. They're productive competitive plants, which means they like to grow a lot of biomass, which means they're super useful for us as people to eat, because we like to eat a lot of biomass. So, and that life cycle strategy means they like to outcompete other plants, which means a lot of them are allelopathic. It's that word that looks like allelopathy, but it's not. It has an extra couple L's in there. It's allelopathy, is how you pronounce it, is the correct way to pronounce it. By the way, if you've seen that word, the correct pronunciation is allelopathy. And one of the most common forms of allelopathy is that the chemicals that hold the seeds dormant, that keep the seeds from germinating, tend to also be allelopathic and keep other seeds from germinating. So and they tend to be water soluble. So when the seeds soak in water, that chemical soaks out of the seeds, and if it gets to other types of plants, especially like garlic mustard is a great example of doing this. Garlic mustard seeds do this. All of the carrot family plants do this. Fennel does this really, really powerfully. All of the sunflowers do this. So even sunflower seeds do this. As the chemicals leach out of the seeds, they'll keep other things from germinating. So we have to be a little bit strategic about this, and that's a great example to lead us into some of our content today. So
I have a follow-up question.
Sure.
Does that mean that if we soak our sunflower seeds, that they won't be allelopathic to other things? Because I want to put in tons of sunflowers, but
the answer to that is yes. And Pamela, you will also appreciate this too with us eating seeds. This is why a lot of times it's healthier to sprout things like oats before you eat them.
Oh, totally. Oh, I'm totally into that.
And because when you do, those same things will bind up nutrients within us, and it's not a huge health impact, but it can keep us from digesting certain nutrients if we eat those. They're called enzyme inhibitors, and the seeds have enzyme inhibitors to keep the seeds from sprouting. So if you sprout them first, remove that water, then they will be less allelopathic and potentially healthy for us too.
Yeah, because there are all these kind of subtle things, like the biophotons, which are, they're from the interaction with the sun and the photosynthesis, and the deal is that they are lost. Half of them are lost in 24 hours after harvest. They're all gone 3 days after harvest, and there's this incredible doctor named Dr. John Switzer. He's in Germany, where he's free to do more or less what he wants, rather than, there's no FDA breathing down his neck. And he's having phenomenal results. And he says that the biophotons are the most important nutrient in the food.
It's pretty incredible stuff once we start looking at how all of these things connect, and how these a chemical like an allelopathic chemical also affects us in both negative ways and positive ways, and it's really fascinating to look at. But if you're tuning into this hoping for a beginner's view of this topic of polycultures, I promise you we're going to get there too. We're going to go backwards and start real simple on things, but we're going to grow in depth as we continue this discussion. So I love, though, that this group of really smart people always has. We always get into some really great, cool, advanced topics. So, any final thought before we go? I'm going to start firing up this here. There I am. I'm going to start firing up this here. Let's see. I want to share my screen. Website. My link doesn't work. Give me just a second. We'll figure it out here. There it is. Hopefully the slideshow link was working for y'all. Here it goes again. All right. And we're off. We can get more questions and have a little more conversation as we go. So, polycultures and guilds. And again, this is a great, since it's one of my favorite topics in permaculture. Here's that front yard garden at Lily House, my last project site. And as you can see, that is a whole lot of plants in one little space. That's the main food garden, and it also grew all of my favorite annuals too. So as we're talking about this, we're not just talking about, and Noah asked about weeds and the benefits of weeds in systems, and absolutely, Noah, weeds can have an just as high an impact in terms of the biodiversity and positive impacts on yields as non-weed plants, but it depends. What we're going to see tonight is that to some degree, just including polyculture, just including more biodiversity, has a huge positive benefit. But we have to be thoughtful and mindful about it. One thing that I would like to invite you to see in this picture is that you see a few big flashes of purple on there. These flashes of purple are, one of them is Monarda, one is Liatris, another one is Speedwell, and each one of those plants is not just being overtaken in competition with other plants. It's not just a weedy mess. Each plant in this picture has all of the room that it needs to truly thrive. And you can see some pale blues in the middle there. Those are huge sea kale plants. One of my favorite plants, sea kale. And the sea kale plants grow huge in this garden, and they're allowed to thrive. They're still intermixed. And there are actually other plants growing literally in a way under the sea kale. So even that is kind of a polyculture, but the sea kale is allowed all the room that it needs to be a healthy sea kale plant. So that's one of the things that we're going for, is that each plant in a well-designed polyculture system and a well-designed guild still gets all of the room that it needs to truly thrive in a really good one. So today's class objective, to help us understand the reasons and goals for polycultures. Why do we want to do this stuff? We've already talked about some. 2, to provide many models to begin using polycultures. So hopefully I'm going to show you a bunch of models that can just take, plug, and play tonight. 3, to understand the principles for creating and designing your own polycultures. And 4, to provide you with patterns that you can use for your garden design by making them and manipulating them and changing them up and adapting them. And this is coming back to our major course objective for the Landscape Transformation Program. And that is, we want to design and install as soon as we can. And this is what we're always trying to get people to do. Whenever I work with people in my programs, I'm always trying to get them to design and install their first locust, their first little plant collection, and get that right. Because if we can install one installation, one guild, one polyculture that works really, really well and takes care of itself so that we don't have to take care of it, then we can take over the world, right? That's a model we can use and expand over our whole yard and help everyone in our communities by using that same model, right? So that's one of our first course objectives. Just another pretty picture of the gardens at Lily House, showing the super high biodiversity throughout, and yet each plant having the room that it needs to thrive. So, benefits of polyculture. So here are just a few. They have a lot of benefits to garden health. They've been shown to increase fertility and plant growth even more than fertilizer or compost. Now that's amazing to me, that there are now multiple studies, and I linked one right there, that have shown that just taking a bunch of plants and cramming them all together into a garden will get more fertility and more growth than actually shoving a ton of compost into that same soil. So that's a powerful reason for why we're doing this right here. 2, they've been proven to improve soil structure and sequester more carbon. They've been proven to increase soil biodiversity, which improves crop health and resistance to disease. Now, this is one of the most amazing things about polyculture, is that now, these days, a lot of people who are into soil, our last classes we're talking about soil, we talked about how important biodiversity in the soil is. And now we know the most important, powerful, impactful thing that we can do to increase the soil biodiversity isn't like spraying the soil with some designer spray. It's or importing the right minerals or any kind of additives. It's polyculture. Polyculture will increase the soil biodiversity more than anything else we know of today. 4, polyculture has been proven to dramatically reduce pest, disease, and weed pressures. 5, they increase the resilience of a garden by providing multiple yields in the same place. So if one crop fails, another in the same space can still provide a yield. 6, they've been proven to infiltrate more water. So they help us hold water and catch water better. And 7, they use space efficiently to increase total yields. So polyculture is just simply one of our most important tools. And again, if you want to talk about it in terms of human health, if we can create gardens that have high biodiversity, then for us, we're getting a ton of different nutrients into our diets too. Does anyone else have any other thoughts, comments, benefits of polyculture that I'm leaving out? When it comes to pests, one that a lot of people will talk about is that if you have just a field of corn, which is called a monoculture, then a corn earworm shows up. That corn earworm is like, oh, the promised land, right? Corn as far as the eye can see. It has found the ultimate buffet to invade and procreate, and there's no habitat for any of the things that eat corn earworms, and there's no habitat for any of the things that would compete with corn earworm. So the corn earworm populations just explode rapidly, which is why pretty much every study has now shown that, ironically, pest populations are higher in fields that are being heavily sprayed, and monoculture fields are being heavily sprayed for pests. The only thing the spraying does is prevent the ultimate, the long-term loss in terms of the yields. It keeps the pests from eating the important part of the crop, the seed head and stuff like that. But pest populations are usually higher overall than in a polyculture field that's no spray. So kind of another important thing there to think about. Same thing with diseases, but if you have a polyculture, then it's harder for the corn earworm to find the corn. And it's got to dodge around all of the things that might eat it, because if you have beneficial insectary plants, then you're also going to be getting like lots of wasps in there and stuff. And wasps want to eat the corn earworms too. And birds want to eat the corn earworms. And lightning bugs and all these other things will show up and eat the corn earworms and other pests if we can provide habitat for them, which is what polyculture does. Anyone else have thoughts, comments, points about the value of polyculture?
Does it not lower the work of the gardener?
I think there are two different perspectives on that, which gives us an introduction to two words we're going to use tonight. One of the words is just polyculture, which means planting of multiple types of plants all in together. But tonight we're also going to talk about a special form of polyculture called a guild. And a guild is a polyculture that's designed to function like a natural plant community. And those, we look at all the work we're going to try to do, and we try to recruit plants to do the work for us. So in some polycultures, some researchers have looked at this, Noah, and they've found that sometimes the polycultures increase the work in the field because the farmer would have to go and harvest the corn and harvest the beans and harvest the squash. So it might be easier from the researcher's perspective to just harvest the corn, right? So that would be less work to a researcher. But we could still design polycultures to intentionally reduce our work. And if we're talking about the benefits of polyculture, if they're doing fertilizing for us and doing weeding for us and doing pest control and disease control for us, that should be reducing our work too. So good point. Anyone else have any? What we're looking at now is another good reason for polyculture, and this is biome productivity. This is how many total calories of sun an ecosystem can turn into calories stored up in plants. So plants are considered the primary producers, and the overall biodiversity of any ecosystem or the world itself is limited by how many calories plants on this planet can produce. So as we can see from this, the more biodiversity, generally speaking, the more biome productivity there is. So in this chart here, we see agricultural land, but I want you to keep in mind that blue bar for agricultural land it's right in the middle there, is cheating. It's a little bit cheating because this is specifically irrigated average global agriculture land. So it's really pretty high. I've seen other things that have like unirrigated cropland, and they tend to be, down more, really only a little bit higher than like open ocean or tundra. So they have very low biome productivity. So agricultural land only has high productivity once we're fertilizing it and putting and irrigating it, using fossil resources to increase the productivity. So that's a little bit cheating, isn't it? I think that's cheating. But as we look at these other things, once we jump up to temperate forest, it has literally 2, and in some cases 3 times the productivity of agricultural land. This means that there are twice to 3 times, and once we get up to like tropical rainforest, it's way off the chart, right? So by using polyculture, we create more potential calories, which means that we have calories to feed people and calories to feed wildlife at the same time. Because one of the huge problems of today is loss of biodiversity and this mass extinction event going on. So this chart shows in green on the left the total global biomass of wild animals in 10,000 BCE. And as you see, as we've used fossil fuels and primarily what you're looking at is fossil fuels and fertilizer, we have increased the amount of global biomass by 7 times, but it's almost entirely humans and livestock animals. And wildlife has almost completely gone away from this by 2050. So one of the promises of permaculture and polyculture is that we can find a way to support human life that doesn't just exclude animals, that we can create more total calories so we can sustain biodiversity and non-human animals and also sustain people. So there's another big picture important reason why we need to talk about polyculture. A cornfield can never do that, because a cornfield to all other life is a desert. It supports no life but humans, right? So this becomes a big issue. One last chart here on the benefits of polyculture. This just shows carbon sequestration in 2 different forms. Basically, well, we don't have to get into that, but basically it shows 2 different forms of soil carbon. And what you see in this chart is the difference between annuals and monocultures on the left, and monocultures of perennials in the middle, and on the right we have polycultures of perennials, and we have nearly twice as much, in some cases twice as much or 3 times as much carbon sequestration in the soil, which builds soil fertility, builds soil structure, and fights climate change. We do that 2 to 3 times better when we have perennial polycultures than we do with annuals and monocultures. So again, another really important reason for polycultures. So with all of that, oh, and they can really help us transform landscapes quickly, which is a really big deal. So with all of that, are you excited to talk more about how to actually do this thing? Anyone have any questions or thoughts about these benefits of polycultures? I think you can see why I think this is one of our most powerful permaculture topic, because of how many things it can potentially help us with. Okay. Okay. I am going to continue on. And just to get started, I'd like to start with some big picture ideas on polycultures. So let's start with a cool example. If you haven't seen it before and you're watching this and you want to take a screenshot, this is in my book, which is right over here behind me here, Beauty and Abundance, if you're just catching this. And this is a classic permaculture design, the Vegetable Garden Makeover Guild. And this is one of those things that, like Noah and I were talking about a minute ago, which is a polyculture designed to work like a natural ecosystem. So this shows us just one easy way we can put in a bunch of plants together that you could take and use and transform an annual garden that isn't working well for you into a dynamic perennial annual polyculture. So this, oh, thank you, Noah. This guild is surrounded on the edges by something we'll call fortress plants. And these fortress plants actually keep weeds and grasses from invading into the annual garden. So that's one of the things we're doing is weeding work. So we're getting plants to do this weeding work for us. And it has a swale built into it with a deep mulch basin. So this garden is designed to water itself. It has, if it has edges like rocks or bricks or logs around it, then we have those planted out with some things that will help keep grasses from growing into them. It has nitrogen fixers built in so that it's also getting nitrogen built right in to the garden. So the plants are supplying nitrogen fertilizer for us. And the whole thing is covered with deep mulch. So that, and it has plants that we can chop and drop to mulch this garden for us, so that it's a garden that really takes care of itself. Then when it's time to plant my tomatoes or peppers, I can just go out, part that mulch a little bit, and put that tomato right into there. I have some videos on YouTube talking about this, showing me do this. And the gardening work is done for you. That's it. You put that plant in there, it's done. You've got a garden system. It's going to work like an ecosystem to take care of that plant for you. So this kind of design I really love. Just give it a little space in case anyone has thoughts, comments, questions. Okay. Next up, another quick example. Just for anyone who's out there who wants to, get started with permaculture, here is another 101 level permaculture design. You can go and find an article about how to do this on transformativeadventures.com, or actually .org, sorry, transformativeadventures.org. And this is a kind of spiral garden that has a bunch of different types of herbs, many of them perennial, all planted into it, taking advantage of the different microclimates created by these different levels. And so this is another really easy type of garden that is great for beginners, and it's a polyculture. So if you start with something like this, it's always a way to jumpstart your gardening with experience of easy, permanent style, perennial polyculture gardening. So I love these two examples. And for those of you who are looking to become teachers and do the landscape transformation program with clients and students of your own, you know, if you can get people to start with a few projects like this, man, their gardening just becomes a win. Their whole perspective on gardening is transformed. All right. Just leaving a little space. Okay. This brings us to a question I have for you. Let's see. And without looking ahead too much, what are some types, people who study polycultures can break them into different types of polyculture design. And this can help us in thinking about how we design polycultures. And I'll give you a hint. I've already mentioned one, a guild, right? So a guild is a type of polyculture that is designed to mimic a plant community. Are there other types of polycultures we know? Or you know, or you have familiarity with? Well, it's kind of an abstract question. So usually people can bring up some ideas. You may be thinking of them at home right now as you listen. So some of our types of polyculture, and by the way, if you've been trying to talk, everybody I think is muted. So before you try to talk, make sure you unmute. And again, of course, feel free to ask Zach any questions as well. Right. So some types of polycultures we're going to talk about tonight are integrated polycultures. And this just makes a point that in a broad way of thinking about it, any home garden is really sort of a polyculture. Because if you have a row of tomatoes and a row of peppers and a row of broccoli and a row of cabbages, really that has more biodiversity than a cornfield does, right? I mean, pretty obviously. But if they're spread out and all that, they're not making the maximum benefits. As we said before, we get the most benefits when the plants are sharing soil together. So if we have rows or beds of like a bed of cabbage, a bed of broccoli, a bed of tomatoes, a bed of peppers, that will not have as much biodiversity or benefit as what we call an integrated polyculture, where we take all those beds and go, blah, blah, right, and smush them all into one bed. So dynamic polycultures is kind of a cool term. They sound like kablamo. But dynamic is just talking about how they change in time. So when we talk about dynamic polycultures, we're going to be talking about time-based polycultures. One type of which could be crop rotation. Crop rotation is considered to work theoretically because it's a type of polyculture. It's a polyculture that exists in time. So really, even if we have a field of corn, if we do a corn, soy rotation, and then a cover crop after that, especially, we have a polyculture that exists in time. It's still not as beneficial as having all the plants together. But like we were saying before, the benefits of polyculture are linear. So even a little bit of polyculture like this has a ton of benefits, which is why crop rotations do work better than just growing corn and corn and corn and corn forever every year, right? Interplantings. interplantings are a type of polyculture where we're being careful about how the plants play together. For example, corn is tall and pretty upright. And so maybe if we do a row of corn, we can fit in a row of turnips or something small that doesn't mind the shade in between the corn. So that would be considered an interplanting. It means that they're thinking about how the crops take up space and nutrients and stuff like that together. So that's interplanting. The next on our list is companion plantings. Companion plantings are great because they get us to do polyculture. Now, I'm going to say something a little bit curmudgeon-y about companion planting, which is that companion planting works. It works great. So that's where we start. Start with the idea that if you're doing companion planting, you're doing polyculture. But it turns out that probably the reason why companion planting works is 90% of the time because it increases biodiversity. Again, this gets us to something that ecologists call the biodiversity resiliency principle. And the biodiversity resiliency principle states that the larger number of species you have in a system, the more benefit, the more resilience to pests and diseases that it confers to the individuals in the system. So individuals in a high biodiversity system will be healthier than those in a low biodiversity system. Now wait, because this is a magical point. This includes you and me. So that when we humans exist in a high biodiversity environment, it enhances our health. As I was saying before, the best way we know to increase microbial biodiversity is to increase plant biodiversity in an area. As we do this, I end up, and then I go out into the garden, I get that biodiversity all over me too. Now that sounds a little gross, but it's actually not. We're supposed to have that. And researchers have now been studying this and found it's related to what's called the hygiene theory of immunology. For the last 100 years, since Kellogg, started telling people we wanted to get rid of all of the microbes from everything, we have been releasing, scrubbing ourselves free of microbes with Lysol and so on, and including our insides, right? And this makes us sick, we know now. So now the science is returning to this idea that we need to become high biodiversity polycultures ourselves as humans, and this enhances our health. So this is one of the things that I love to tell people when they tour my garden. I tell them this story about polycultures, and then I say that interacting with our type of permaculture gardens is a health enhancing event, because they will be going out and picking food that's high biodiversity and touching plants that are high biodiversity and interacting with a high biodiversity ecosystem. And Joe says it's right, because that's why he has no pests in his veggie gardens. It's true. And this is something, Joe, that blew me away the more I played around with it. And it usually has a curve, right? It usually takes a while for high biodiversity to kick in. But once we get like three years, maybe 5 years into a high biodiversity environment, a lot of the pests and disease issues disappear and go away. And we have had science to reinforce this now for a long time, since the very first Earth Day. This was a major premise of Rachel Carlson's book, Silent Spring, was looking at the research showing that as soon as we start eliminating biodiversity, we start getting an explosion of pests. And if we can go backwards, we get a huge reduction in pests. Yep, 3 years is about right. Glad you've had that same experience, Joe. Anybody else want to reinforce that with their there are issues. Sometimes our permaculture gardens will start with some issues like some slugs. Maybe we'll have a few infestations in those first couple years. But once the infestations show up, that's when the critters that eat the infestations show up. Then they bring things under control. So it's this magical cycle that happens. We have to be careful and gentle in interacting the first couple of years. If we do that right, then our pest and disease control squad show up to protect the garden. Just going to leave some space after that, because those are some big issues. And just to bring back one more idea to this. While we're talking about companion plantings, that's why companion planting probably really works. So researchers have now studied a lot of companion plantings, and 90% of the time, not always, 90% of the time, the companion plants really do show benefits, but not any better than the plant plus any random other plant. So if we look at a thing like one of the companion planting rules is carrots and tomatoes, right? And so that works. It absolutely works. So I plant carrots with my potato or tomatoes a lot. Why not? It works. But it turns out that carrots plus tomatoes probably doesn't work any better than carrots plus any other plant and any other plant. And the more we increase biodiversity, usually the more we increase the benefits to our plants. There are some exceptions like marigolds that actually do have been found to impact and decrease and attack soil nematodes, negative nematodes. So like if you have that problem, if your tomatoes are prone to nematode attacks, planting marigolds to attack the nematodes really does work better than planting carrots or whatever else you're planting. But those cases where true companion planting benefits arise are small in the research literature, whereas just the benefit of just increasing polyculture, just increasing the biodiversity is really robust in the research. I think I hear someone who unmuted. So anyone have comments?
Yeah, I wanted to say that I really noticed a beneficial effect on the slug population. And I live in Portland, Oregon, which is the slug capital of the world. It's rainy, mild winters. Oh God. And I just kind of got late. I just got sick and tired of messing with the slugs. I just got tired of it. And after about 3 years, I just thought, wow, I'm just not seeing what happened to the slugs. Because I used to just torture myself. Oh God, it was ridiculous. And it just took care of itself. Now I do have a really picky question about the nematodes, because Elaine Ingham said that there are beneficial nematodes and destructive nematodes. So I'm wondering about the marigolds and the beneficial nematodes, or do they nuke them all?
Yeah, the marigolds actually will hurt the beneficial nematodes too, which is why overall more biodiversity is really the best way to impact the negative nematodes, because because the beneficial nematodes will eat the negative nematodes. And what is one of the things that we can do to increase positive overall nematode biodiversity and beneficial nematodes? And as we do that, the destructive nematodes back off. So this is really proven research that the best way to solve a negative nematode problem is to increase overall nematode biodiversity and overall soil biodiversity. As we do that, the destructive nematodes become less destructive. Some of the ways to do that: mulch, no-till, polyculture, leaving plant residue, leaving soil coverings and things like that. Never spray. Nematodes have been shown to be extremely vulnerable to spraying, and plastics, soil plastics and plastics in contact with the soil have been shown to be really destructive to the beneficial nematodes and helpful to the negative nematodes. There's a really good reason for that too, which is that the negative nematodes primarily eat our plants, right? So when we plastic the soil, we hurt all the nematodes, but the first ones to recover are the ones that have a food source, which are our plants that we want to grow. So they come back first and have stronger populations. The beneficial nematodes tend to like to eat other negative things like negative nematodes, the bad nematodes. And they won't show up unless there's happy, stable, secure nematode populations for them to eat, because they don't eat our plants. So, again, this is an idea. It shows us how this biodiversity resiliency principle works. It means if we have a healthy, lush ecosystem, there's going to be good guys eat the bad guys and to outcompete the bad guys. It's just as simple as that.
Wow, cool. I love it. Thank you.
Yeah. And Zach has a question. If polycultures could help with broad feeding pests like locusts, yes, that becomes a little bit difficult with that question. The reason why, and this is again, there's research covering exactly this question, Zach, and that was presented in Rachel Carlson's Silent Spring. So this is old, well-documented science. In fact, it's actually in this book right here. This is, can you see that? This is, I like to collect, this way. I like to collect antique agriculture books and horticulture books. I have the initial 3-volume set of Leopold Hyde Bailey's Encyclopedia of Horticulture right here, which talks about this. So this is old, well-known science. And what the science says is that once you start reducing biodiversity in a region, then it allows pests like locusts to get out of control more easily. So a lot of places today where we're seeing locust population expansions, the fundamental cause is the decline in biodiversity from monoculture agriculture. That's what causes the locust booms. Simple as that. So the solution to locusts is polyculture and to do something about that. But it's a big, broad, much more broader regional kind of perspective, right? Because if I'm living in an area and a locust swarm comes through, they're probably going to have a big impact on my polyculture garden too, right? Maybe less than just something like a cornfield, because they're still going to have to compete with the vespids, the wasps, and fireflies, and all these other things that are out there trying to protect my garden. So my garden may be a little bit protected, but it's still going to be more vulnerable because of the monocultures that are happening around us. So I'm sorry, it's kind of an unsatisfactory answer. The long-term thing there is we need to return to older, better, more polyculture forms of food production, and that will be a better solution to resilience to locusts than what we have. Joe also mentioned another clever trick there for slugs. A lot of permaculture gardens, once you start doing the stuff and stop spraying, we get slugs. It's like one of the first rules of permaculture is that early on, there probably will be slugs. It's just simple as that. And we have to try to manage them gently because, like Joe said, some of the things that eat the slugs, and like we already heard here, will show up and dramatically reduce the slug populations. It was rare for me to see 1 or 2 slugs a year at Lily House, and rarely did I see slug damage. And at my new garden here, the first couple of months, the slug population was nuts, but because of super high biodiversity, and I think because the plants came from a garden with super high biodiversity, I imported a bunch of pests or beneficial insects with my garden. And even in the first year in my new garden, the slug population was done by like June. And by June, there was no slug damage on the garden anymore because my plants came from a super high biodiversity garden. Think about that. Isn't that an amazing benefit? That's why you order from permaculture plant nurseries where they're doing no spray, high biodiversity gardening, because you're also importing beneficial insects and microbes with your garden plants. So one of the big things that eats slugs, is the firefly genus of plants, or bugs, insects. So that whole genus. So in the Pacific Northwest, we don't have, or there are no fireflies where Pamela Melcher is at. But there are fireflies. They just don't light up. They're the same genus of insects. And the ones up there also eat slugs just the way the ones that light up do. So there's actually there are species of this genus found everywhere around the world. So I can guarantee, and they all do the same thing. They like some areas of unmown grasses. You have to have unmown grasses, and then they will eat slugs wherever they are found, and they're found pretty much everywhere in the world. Just leaving a little space. We just dropped some heavy benefits of polyculture right there. And the last thing on my types of polyculture list are guilds. And guilds are polycultures designed to do exactly all of this stuff really well. On that note, tonight I would like to go till about 7:20, and we'll take a little bit longer break in the middle of class if that's okay with everyone. Keep in mind we're recording this, so if you have to miss a bit, it will be there. Feel free to go and come back. I'll still just be talking about plants with y'all. But we're going to go until then and take a longer break, and then we'll come back and do a second half of the class after that. So this gives us a chance to talk about some basic concepts in how to design polycultures. So I've already shown you a few polycultures that you can just grab and take and plug into your garden and make them work. And now I'm going to talk about some of the reasons that they work and when they don't, and how to make sure that they work well. So, and I'm going to check on the chat real quick. Oh, and someone asked if polycultures will keep stink bug populations down. Yeah, I can even tell you for sure, Zach, that there have been some studies of this, like in Japan in particular, and 100% high biodiversity gardens will not have bad stink bug or Japanese beetle populations. I can say, and I have heard this again and again and again from people on the permaculture journey. My experience at Lily House was that early on, especially, pests would show up. And when they show up, they have this population boom, right? The populations go up real quick. And then the things that show up, the things that eat the pests show up, and the populations go back down and come into balance. So I had a few months, one of the years, where I had a huge problem with Japanese beetles. And it was one couple of month period in late summer in 1 year. And ever after that, they were never a problem ever again, because the populations in the garden for things that control stink bugs came into play. Now, if I had gone, the stink bugs, and sprayed the garden for stink bugs, I would have gotten rid of the stink bugs that first year. And they would have come back exactly the same way the next year, and the next year, and the next year, forever, right? But because of taking that light approach and just hand pick, just do enough to get an acceptable yield, accept some losses for a bit, and allow the predator populations to show up. And I had the same thing with stink bugs. I had 1 year where the stink bugs did a ton of damage to, yeah, I'll make sure you have the link to the slideshow. I have 1 year where the stink bugs did a lot of damage, especially to my Asian pears. It was the only time anything has ever hurt my Asian pears, but they were getting the fruit. I would say maybe 50%. So the Asian pears still produce like 50% clean, beautiful, perfect fruit, which is amazing in my region, which is a super high pest region. So the fact that so Asian pears are a good plant to begin with. They're going to be one of the best, easiest fruits we can grow in a temperate region. But that year, the stink bug population hit like 50% of those fruit. And I thought, oh, there it is. My Asian pears are finally vulnerable. But the next year, they were gone again. And I still saw stink bugs. They were still there. I still see an occasional Japanese beetle. And I still see an occasional slug. But there's not a huge, but I don't lose the whole garden to them. And noticing a little bit of damage here and there from them is all I ever get. So the idea isn't that we'll have a completely pest-free garden. But the idea is the pest problems usually come back into a range where they're acceptable to us. Like Joe was just saying. Joe was like, I don't have any pests in my garden. And that's the experience that a lot of permaculture people have had this. And Pamela said the same thing. So it's not just me. We're not just lying to people. This stuff really does work. And it takes a while for it to kick in. But once it does, it really does work. And it's not that those things are gone. Pamela still has pests and Joe still has pests. They're there. And I still do too. But we barely notice the damage they do. That's what we're going for. Okay, good question. Thank you. So, some basic concepts here. We're going to talk about 4 ways to do and design polycultures. We're going to talk about a color by numbers approach. This means you can just take some of the polycultures that I'm going to teach you tonight and use them in your garden. I already showed you 2. They're great places to start for gardens. So if you wanted to, you can just stop at that color by numbers approach, right? Simple as that. Another one is ecological modeling. This means we actually look at an ecosystem on similar soil to ours and see what it does, and then try to imitate exactly that, but maybe using more of the plants that we want to see as crop plants. Make sense? Excuse me. So we're taking a natural ecosystem and slightly tweaking it to make it more productive. That's ecological modeling. I always talk a lot about one of my favorite polycultures, the Native American created polyculture that you can see at Turkey Run State Park in Indiana. It's an amazing old growth food forest system, and it's super high biodiversity, super healthy, super productive, and that makes a great model to build a home garden in the Eastern Woodland region, because and then maybe we can improve it in some ways with some other plants that we might like to include, but it's a great model to start with. The next version could be polycultures for nerds. This is if you really want to understand nuts and bolts and get in there and figure it out. The reason why I'm telling you all this is because each one of these approaches makes sense. They make sense to different people, right? So some people will just want to take one of the models that I'm giving you, and you can see there are a bunch of the slideshow, and you can just take one of those models and plug it right into your own garden, and it'll probably work a little bit. You might have to fiddle a little bit given your local conditions, but and that's great. If you want to stop there, cool. If you want to keep going with it, you can look at your own ecosystem, what's around you, and try to imitate and import some of that. Or, for all of you tonight, as we continue on through the class tonight, we're going to go deep into some of the epic nerdy stuff about how we can make these work. And then finally, what I call dynamic polycultures for intuitive types. What this is a foolproof way to do polyculture well. So this is another one. I'm trying to make this stuff as simple as possible, right? So here's a foolproof way to learn how to do polyculture. You take as many plants as you can, as many species as you can, and jam them into a small space. But you make sure that all the plants have the room they need to grow as they grow, right? So this is a classic way to do polyculture. We're going to talk about it more in just a couple minutes before we take a break, I hope. So we could call this dynamic polycultures for intuitive types. Now, there's a best practice number that's been thrown out in a lot of the permaculture movement, and the magic number is 30. And there's some research to show that this is a pretty good number. And there's a lot of experience from people in the permaculture movement. So if we take like a 30 by 40 square foot area, we're talking about a 30 by 40 square foot area, just as approximately that, and you try to include at least 30 species of mostly perennial plants, not varieties, but species, that's important, into that one area, then you're giving nature what it needs in terms of biodiversity to try to make something work. So usually, if we can take a small area and bomb it with, in fact, I would probably even say my rule might even be to try to fit that into like a 20 by 30. So if you can fit all that into a 20 by 30 type size space and have like 30 species in there, probably it will pop and become a really good polyculture. Then all you need to do is watch the plants as they grow and make sure that they're not out competing with each other, making sure that they're cooperating more than they compete. Because this is our golden rule for tonight, our golden rule for polycultures. It's really one of permaculture's main rules, is cooperation over competition. It's one of our Mollison principles. So what we want to do in a good polyculture garden, our golden rule is to find ways to maximize the cooperation between our plants and minimize the competition between our plants. So that's what we're always trying to do, which makes a great discussion. Well, let's think about that for a second. What are some ways we can minimize the competition between our plants? I like to ask this as a question because it's pretty intuitive. So what are some ways we can minimize the competition between plants?
Layers.
Layers, absolutely. So if one plant grows tall, we can put another plant in its shade, for example, and so they're not competing with each other in space.
Maximum soil fertility.
Absolutely. If we're providing great soil fertility, then and great soil in general, then the plants will not have to compete too much in terms of getting their nutrients. No, would you say the same applies for water, right?
Those two go together.
Absolutely. Any other ways we can minimize competition? We talked about. Oh,
Can you hear me? Diversity of flower shapes.
oh yeah, diversity of flower shapes and diversity of plant shapes too, right?
Yeah.
Absolutely. Yeah.
And whether the focus is on the root or the leaves or plant parts.
Yes, absolutely. That's another great example. And I'm going to throw in one last way, which is time. So we can talk about time-based polycultures too. So we can have plants where one plant likes the spring and another plant likes the fall, for example. So then they're not competing with each other because they're divided by time. So we're always trying to think of ways that we can minimize the competition and maximize the cooperation between the plants.
And I guess also diversify throw some plants in that like bacterial soil and some that like fungal soil so that they all kind of get their little, because every soil is partly bacterial and partly fungal, so they'll all get the little pieces they want.
Yes,
And
absolutely.
I have a question about this because I tend to overthink things. Is it better to just kind of just throw them all in there, or does it serve us to spend great amounts of time analyzing these variables?
Yeah, well, it kind of comes back to these 4 ways to do polyculture. And, well, I don't know, let me throw that back at everyone. Does someone else have a good answer for that? I have an answer for it, but I think it's pretty intuitive if we think about it for a second. Do you have an answer for it?
Me? No, I asked the question.
Oh, I know.
I mean, it's kind of, well, either I overthink it or it's totally random. And I think maybe a middle ground would be wise.
What I like to say is that it has to do with things like permaculture zones and what our goals are and how much land there is, for example. Because if I just have a tiny little postage stamp size garden and I have, 4 or 5 beds on an urban lot, then taking the time to do something really precise, and I'm just going to show you some examples in here. Here's an example from my book. Doing something really precise, like this tomato pepper guild, the Solanaceae guild, means that we're being really precise with how the plants fit together. So we're maximizing the cooperation and minimizing the competition between them, and we're getting super high yields. So something like this, being really precise, makes a lot of sense on the small scale. But if I'm blowing this up to something like a full acre, then I just can't, right? There's no way I could micromanage every square foot on a full acre. So then it becomes more that strategy of 1, ecological modeling. How is nature naturally creating polycultures that work well on broad acres in my landscape, in my ecosystem? And a matter of just putting together a bunch of biodiversity and making sure and letting it fight it out and let it work, right? So those become so zones in that way is one of the main zones, and goals, Pamela, are how I answer that question. And that's how it breaks down. It's like, how much do I want to prioritize, and time versus yields, right? I can get a higher overall yield if I take some time and micromanage the design, but that takes more time. So maybe I'll have a lower yield, but I can just take a bunch of seeds and go blah and throw them on the bare soil. And that will create a polyculture for me if I'm careful about how I harvest, right? So it's just all a matter of the goal there, thinking of goals and thinking of zones. Does that sound about right?
Yeah. And I mean, Masanobu Fukuoka, the model for all of us, just what he did was his technique was to put things in seed balls, which made them more likely to germinate. And then he just watched what grew, just let them teach him.
Yeah. And to throw out one more great type of let's see if I have it here. To throw out one more great type of polyculture that everyone who's kind of watching this can feel free to grab and use. If you look at transformativeadventures.org, go to transformativeadventures.org, you will find a list or a page, and you can search for the Lily House Polyculture. It's also in my book, Beauty and Abundance. If you feel like getting a great permaculture book, if you're just kind of joining this with Zach, if you feel like getting a great permaculture book, this has a bunch of guilds in it. And one of them is called the beautiful abundant scatter sown polyculture. And the whole idea of this is a similar thing, Pamela. It doesn't use seed balls, but it uses a seed mix. And you basically just take that seed mix and cast them out onto bare soil and let things germinate. And as they come in, we select and we thin things. And as we thin, that's our salad. So this is called a dynamic polyculture because it changes over time. And what we're always trying to do is make sure that every plant has just enough space so that it can thrive, so that the plants nearly are outcompeting each other, but they look pretty dense, but still the plants are just barely touching. So like in this picture I'm showing you right now, which is a beautiful garden by the permaculturist Kate Frey, which I'm going to talk about more tonight, believe me, this garden looks like it's just about ready to be harvested. The gardener here is going to have to make some tough choices about taking out about half of these plants to let the other plants grow in more and expand. Because we always want to keep these dynamic polycultures thinned out so that each plant has enough room to grow. That's one of the biggest, most important rules of polyculture, in my opinion. There's a video on YouTube on growing polycultures, and it's got like 1 million watches. And I think I have to say it's from someone who didn't, in my opinion, understand the literature or the permaculture books and stuff on polyculture. Because what he did is he had a bunch of plants left over when he planted his garden, and he just took them all. Oh, thank you. Noah shared that it's on page 405 of the book is the polyculture I'm talking about. It's similar to the one we're looking at right here. So if you just took, so what he did is he had plants left over. He just took all the plants and jammed them into a small space. And he just let them grow like that. And at the end of the season, his yields looked really terrible to me. I'll be honest. He was playing it up like he was fine with it, whatever. We got like 1 ear of corn. It was like 2 inches long and had 3 kernels on it, and a couple of small tomatoes that were half bug eaten. It was not a very successful garden because the plants didn't have the room that they needed to thrive. He created a garden that maximized competition and minimized cooperation, and thought that that was a test of good polyculture. But we should be more sophisticated than that and understand that good polyculture means minimizing competition and maximizing cooperation.
So when you scatter sow the seeds, do you put any kind of soil or compost or anything on top of them? Like, of course, do it before it rains, I'm sure. Yeah.
No, not usually. If there's going to be a rain, I'll do a small scattering of mulch to help keep the seeds in place. But what I'll also tend to do is I'm very careful about when I plant. So if I scatter sow like this, I'm going to do it and water in the seeds and make sure that they're not going to have a deluge in like the next week that's going to wash away all the seeds. And I'll make sure.
I'm thinking about them having enough water to germinate.
Oh, right. And that becomes the other issue is watching. It's, Pamela, to me, that when I do this sort of thing, I time the weather. So if I'm worried about them having enough water, I will usually wait till I'm going to have a nice wet week, and I'll cast the seeds then. At the end of the week, wet, warm week, I'll usually have excellent germination. So this is an example of that seed mix. This needs to be thinned. And as you can see here, early in the season, the plants are small and they're really jam-packed in there, but they still have some bare soil in them between them because I've thinned. I've been eating them, right? And then as they grow, as I selectively harvest things, you can see here, I'm making choices about what I want to keep and let grow for the season and what things I want to plant in. And so when you see here in this picture is I've thinned out that same bed. So I've harvested and eaten all of that biomass, all those plants. And you can see right in the middle of that, I've actually popped in a new plant. It looks like maybe that's a ground cherry or something like that would take on later in the season, or maybe a bean. It's probably a bean. So as I pull things out, I'm always putting new things in, having lots of biodiversity, and just making sure that as the plants grow, they always have the room to thrive. So this picture shows right after a big harvest. I think I had a class, I had a big party, had a bunch of people over, made a big salad. So I harvested pretty aggressively, used grass clippings for the mulch, and then let the plants continue to fill back in. But all of these pictures show natural management of polycultures in this sort of way. Just casting the seeds, letting things grow, dynamic polyculture, picking and choosing. The tough thing about this kind of garden is picking which things you're going to leave and which things you're going to eat now. So, I pick the plants that look the healthiest and most promising. I leave those. I get an idea of what their overall spacing needs are going to be. And I make these choices as I go, always making sure that the plants have the room they need to really thrive. And this kind of garden ends up with really nice size. Now, this right here looks like I need to pick that one in the middle, right? That's what I'm looking at going, oh, I see 3 pretty nice heads of lettuce. But if I leave them all, they're not going to size up. So I pick that one out of the middle and eat that as this week's salad and let those other 2 size up to become healthier, bigger heads of lettuce.
And I have another question. Before you sow the seeds, do you soak them?
I do not. In this kind of garden, I do not. But I'm very careful about not have, in the article that I just linked to, that I told you about, and that Noah gave the book page for, it mentions not including too many mustard seeds or carrot or fennel seeds. Because as we said at the beginning of the class, those can be very strongly allelopathic and prevent germination of things like lettuces. So if there are too many of those, what I'll often see is people will try this and they'll scatter sow and they'll get only mustard as they had too many mustard seeds in there. So that inhibited the germination of everything else. So if we keep those types of seeds to a minimum, or maybe even just sprinkle those through afterwards, then you'll have better results. Another example might be, as Pamela suggested, soaking them first. Otherwise, I just, for this kind of garden, I just throw these things in there like that. And I absolutely love this style of gardening. To me, it's the kind of gardening that teaches us more about gardening than any other kind of gardening. Because as you do this, you are being forced to observe the plants very carefully, right? You're looking at the plants, you're kind of empathizing with plants. You are thinking, what does this plant need to thrive? How much room does it need? You are doing a very important, very primeval form of gardening that's about empathizing with the plants and seeing what their needs are and nurturing them and helping them thrive, instead of just kind of doing it by rote and following and planting things out and prescribed spaces and all that. So it's a really magical type of gardening, and it teaches you polyculture design. It teaches you what the plants need. It teaches you the best spacings. It's an amazing way to garden and to learn how to garden. So I love it. It's 7:30. I went a bit over when I said I was going to take a break. So I think that means it's break time. Thank you so much for joining. If anyone who's watching really loved this content and would like to join the rest of the class after break, feel free to send Zach a message. And I think I have a place up for it. We'll make the rest of this one class like $25, I think is what it is. So if you would like to join for the rest of the class, please feel free to. and let Zach know, and I'm sure he'll help you find your way back here to us. And if not, thank you for joining. I hope you enjoy your adventure with polycultures. I hope I gave you at least some starting places to get started with this most rewarding and amazing type of gardening, one of my favorite parts of all permaculture. So I hope you enjoyed. Thanks for joining. And I'm going to say so long to, oh yeah, and absolutely, please feel free to share the live stream that Zach recorded with people. I think this is a great little introduction to one of my favorite topics in permaculture. For the rest of y'all, we'll be back. Hey, thanks, Zach. Thanks for joining us. And thanks for everyone who joined with Zach. So wonderful. And for the rest of y'all, we'll be back after break. Let's make it a 15-minute break. So we'll be back in about, let's make it,
Okay. So that was the sneak peek of Mike Hoag's permaculture design certification class or certificate class. And tonight's topic was polycultures. One of my favorite topics in permaculture. One of the things that really grabbed my attention early on about what permaculture could offer. The idea of mimicking a natural ecosystem and getting all the benefits from it, while at the same time saving yourself work and bringing in some co-gardeners with you in the form of birds, insects, all sorts of wildlife that can, bring in fertilizer for free. Can also manage pests. Can also act as habitat for one another. Yeah, it's really cool, especially once you see things starting to work together. And the more biodiversity you have, as Mike was saying, the more juice that system is going to have, and the more resilient it's going to be to the effects of various pests. So early on, there was a question about, what do you do about things like locusts, which just come through and roll over everything and eat everything. And the answer that Mike gave was basically that if you're doing it by yourself, you're probably going to make out better than most people, but you still might get walloped with everyone else. But if we were to do permaculture on a large scale, if permaculture food production was the norm, then you have all sorts of habitat that you're creating at the same time for things that love to eat locusts, birds in particular, because they're also on the wing, are great at eating those sorts of pests. In fact, there's certain poultry, such as guinea fowl, that people buy often just for their ability to eat bugs. And guinea fowl in particular love to eat things like ticks. And then you have, just all sorts of things that you can bring in to help you defend your food, even though they don't know it's not like you're signing a work contract with your, local guinea fowl or whatever. But nonetheless, they perform their task really well. So yeah, are there any questions that any of y'all had before we wrap it up for the night? I would love to hear it. What'd you think of the show? Did it get you more interested in learning more about permaculture? I have that link up there on display. That's transformativeadventures.org. That's where Mike's home base is, where you can find links to his classes. Let's see if I can find that polyculture that he mentioned. Let's see. Oh, he's got a podcast. I don't know if I even knew that he had a podcast. Oh, looks like he's not doing it lately. But I left a link to his book. Beauty and Abundance. I will leave another link again. This is where he puts all his best ideas. So you can check that out. Aphids. We'll get you some info about aphids. 1 second. So anyway, here's Beauty and Abundance. That's Mike's book. Let's see if we can find that Lily House Permaculture or Polyculture Guild. Let's see if we can find that first, and then I'll get to your question about aphids. Let's see. So he has. Oh, so he's got a seed mix that he's listed for what he did with his lily house. So I'll link that as well. Okay, so from what I understand, the best predator for aphids are the it's not the larval, maybe it is the larval form. Let's look up exactly what form it is. But anyway, it's the immature form of ladybugs. They are also known as aphid lions. They're just unstoppable, voracious predators when it comes to aphids. Pretty cool, actually. So here's one from Illinois University. Oh, it's a very, very long link. I wish they wouldn't do that way. Let's see if I can cut this link down at all. See if it still works. All right, here we go. Here's a much more cleaned up link for some info about aphid lions. That's going to be your best bet. You can attract ladybugs to your garden. I would assume that Florida. You mentioned you were in Florida. I would assume that Florida would still have ladybugs as well. So aphid lion larvae. Let's bring this up on screen, actually. We'll take a look real quick together. So it says aphid lion larvae are out and eating approximately 400 aphids a week. That's each larva doing this. They're competing with ladybugs, which are the adult form, parasitic wasps. So these are other bugs that will also eat ladybugs as well. Parasitic wasps, miniature pirate bugs. That's a fun one. Hoverfly larvae. If you want to attract hoverflies, I've not found a better flower to do it than yarrow. If you can find yarrow, hoverflies just, I mean, it's like a buffet to them. So they'll come in, they'll get a little drink of nectar, and then just kind of hang out in the area. And they eat tons of pests. Hoverflies are some of the best predatory insects that you can attract. Predator stink bugs, which I guess is kind of, a mixed blessing on that one. Praying mantises, which are wonderful broad spectrum pest eaters. Doesn't get much better than a praying mantis. Assassin bugs and damsel bugs, also great broad spectrum feeders. The damsel fly larvae, especially, I believe. With this plethora of beneficial insects on the job, University of Illinois horticultural educator Kelly Alsup urged gardeners not to use chemical sprays to get rid of aphids. Aphids are phloem feeders or plant sap suckers, and this is the reason that you'll see them often being tended to by ants. Ants will actually treat aphids like cows. They'll herd them around into their favorite crop, and the aphids stick their little mouth parts into the plant and they suck out juice, and then the ant comes by and like brushes up against it, and it gets it to release the drop of, they call it something like dew. Basically, it's basically sweet liquid that comes out of their butt, and then the ant eats that, and ants love it. You can actually use that to your advantage too, though, because you can, if you plant the right sort of crops, they can be known as what are known as like trap crops. You can have the ants herd all the aphids to that crop, and then it's something that you either don't care about as much, or it's something that can take the pressures of aphids much more better. And a good example of that is like a good sturdy sunflower. The ants will herd it over to the sunflower, and sunflower is pretty tough. It doesn't really succumb that easily to the aphid pressure. And also that puts them all in the same place. So if a predator does come through, although the ants will try to fight them off, it's still going to have a better chance of eating up a bunch of those aphids if they're all together, right? Oh, got some more questions. Yeah, Yarrow. I'll quickly post a link to Yarrow. Yarrow is a great flower in general. Relatively low growing. Flowers for a large portion of the year. Oh. And it's been used for centuries in traditional medicine. It's actually the plant that Achilles was said to have used to try and staunch the blood after he got his famous injury. Of course, it didn't ultimately end up working for him, but it does supposedly staunch blood if you apply it in the right way, which is one reason it's also called staunch weed. All right, just reading a little bit about it here. All right, so this is a medicinal page about yarrow. I'll just give you the Wikipedia, but that story about Achilles using it, that's the reason that it's called Achillea Melanofolium. So melanofolium means 1,000 leaves because it kind of feathers out. It's very feathery in its appearance. It's pretty, and it grows pretty much anywhere you put it. It doesn't need to be watered. Doesn't need anything really. But here's the one for yarrow. Yeah, that's right out of their butt. It's actually not that different than things like honey. I guess honey doesn't come out of bees' butts, but still, it is something that's been processed by a bug that is sweet that another animal eats. So in that case, it's an ant eating butt juice from an aphid. Honey is more like digested nectar from a bee. Anyway, here's the one for yarrow, so you can take a look at that one. All right, so I'll go back to that article we were reading. Okay. So they congregate on growing tips of garden plants or in the underside of the leaves. They are small and round and produce a frass excrement called honeydew that collects on the plant's leaves, making them sticky. A garden's aphid population builds at a very high rate due to asexual reproduction by the females giving birth to already pregnant clones. Female aphids can produce 5 to 12 offspring in a day. Green lacewing are 1/2 to 3/4 of an inch long. They have green bodies, golden eyes, and intricate lace wings. I'm sure you've seen them in your garden, especially in the middle of summer. They tend to mass up a lot. And this is exactly as you would imagine. They have very fine, transparent, lacy wings. They hold upright over their bodies. The green lacewing adults will fly from flower to flower, eating nectar, pollen, honeydew, and small insects. When an adult female comes across a patch of honeydew and aphids, she will lay her white oval eggs, which remain connected to the plant by a thin filament. The green lacewing larvae, or aphid lions. I've only heard of ladybugs larvae being described as aphid lions, but I guess in this case they're referring to lacewing larvae. Okay. Or aphid lions have long, hooked jaws protruding from their heads, making them look more like a miniature alligator than lions. I guess they just call them lions because they eat a whole lot, like a lion does. As soon as they hatch, they begin eating, injecting enzymes into their prey that digest the internal organs. Ooh, fun. That's a fun way to go. Then they suck out the liquidated body fluids. So they are basically like spiders in that regard, huh? They digest things on the outside. Actually, a lot of bugs do that. That's what flies do as well. So they send their digestive juices out and then they slurp it all back up. The larvae will eat spider mites, small caterpillars, thrips, mealybugs, which we're having a problem with in our apartment here, whitefly, which we also have in our apartment, and other soft-bodied invertebrates. Aphid lions will eat for 1 to 2 weeks before pupating in white, round, silken cocoons on the concealed parts of the plant. Adult green lacewings emerge and live for 2 to 3 months. Depending on the genus, the insects overwinter in bark crevices or protected locations, either as adults or in the pre-pupae stage. They emerge next spring from when the flowers appear. Depending on temperature and weather, there can be 1 to 4 generations per year. An infestation of aphids could be just what your garden needs to increase diversity, said Alsop. The aphid population will attract beneficial insects and pollinators, as well as birds, bats, and larger insects looking to dine on them. Many chemicals labeled for garden use can harm beneficial insects and prevent their return. Treat only if you see severe plant decline or suspect aphids or phloem feeders are transmitting disease. I would say just try not to spray at all. Like, that's just a good general rule. You're always going to do, there's going to be a lot of extra damage caused to other life forms that you want to keep around every time you spray, even if it's labeled organic, even if it's, something like neem oil or something like that. There can always be unintended consequences. The best defense is a defense that works all the time and that you don't have to keep resetting or recharging or respraying or redoing anything to. You set it and it goes. And the only way that works that I know of is to attract in living things, because they will work for you all the time. They won't they won't expect anything else in return. They'll just take what they eat as basically as payment. All right. As a first step, use water sprays or biopesticides such as soap or neem oil. I disagree with that. An alternative to chemical sprays. Neem is still a chemical. It still can kill things, just because it's from the neem tree and it's quote unquote natural. Doesn't mean that you're not going to have some unintended consequences. So really be careful with that, especially with like broad spectrum pest feeders like spiders, praying mantises and stuff like that. They can really be susceptible to these supposedly safe sprays, and you want to have them around. Above all, inspect your garden plants and look for signs of garden pests and the beneficial insects that prey upon them. So there you go. Yeah. So they must have just been waiting to come out with the right conditions when you brought that stuff in the house, Sam. Okay. All right. Anything else you guys want to talk about before we close out for the night? Let's see who is on right now. No, I don't know that I want to do a larger streamer necessarily. Let's get some more exposure to some smaller creators. So I think we might do Sen's rules today. Yeah, give that article a read. I'll post it one more time. Where did I have that? Oh boy, now I'm not gonna be able to find it, am I? Oh, here we go. So here's that article about aphids once more. Oh, everyone ran away. Well, we still got one person to raid with, so that's what we'll do. Looking for some more cool content? I highly recommend Sen's Rules. Looks like they're doing some music tonight, huh? That's cool. Should be a fun time. Post the link to that one. You're quite welcome, Sam. Always happy to help. Have a good night yourself. And hope to see you all Wednesday. We'll be continuing on with Alexander Berkman's What is Communist Anarchism? Getting into, we're coming through the part of the book where he's describing his experience with the Russian Revolution. So it's been very interesting to hear. Yeah, Sen's Rules seemed pretty cool too. I'm not as familiar with them as some other people, but I always do like to support smaller creators. And we'll start the raid. Have a good night, everybody.